Now we can use integer division even when it doesn't divide evenly. So for example, we might have, let's say that x is 6 and y is 22. Now x does not divide 22, right? There's going to be, it doesn't divide it evenly. So we couldn't say x divides y, but we could use integer division. And when we use integer division, we have two things happen. We have a quotient, and that one tells us how many times that will go in. So how many times will x go into y? In this case, 6 will go into 22 3 times. But that doesn't tell the whole story. That only tells us the 18 part, and that's not 22. So there's a remainder. That rest is the remainder. So when you divide 6 into 22, it'll go into it 3 whole times completely. And then there's a remainder of 4. So to tell the whole story, you need both the quotient and the remainder. Now we're going to use some other numbers. So we're going to use some abbreviations as we work through the details on this. So for quotient, we're going to call it Q. We're just going to call it Q, right? That's the quotient. And that's the answer. We're going to use N for the number. And that is, for in this case, that's the 22. Okay? And D for the divisor. And in this case, that's the 6. So we can do, right? So we have the quotient, the number, the divisor, the quotient, and we need one more, and that is the remainder. So let's go ahead and we'll use R for the remainder. And there we have R is the remainder. All right, and those are our abbreviations for all of those things. Now, there are some details we need that are important. And the divisor is not always going to be 6, right? It's going to be whatever number we're dividing by, and the number is whatever number we are dividing. So there are a couple of things that are important for us to understand. So the divisor cannot be equal to 0, right? Cannot be 0. Now it can be negative and it can be positive, but it just cannot be 0. And again, we're working exclusively with integers because we're doing integer division. And now what about the remainder? The remainder actually has limited values as well. So if we're dividing by 6, what are the possible remainders? So if you think about this, if you're dividing by 6, can you have a remainder of 0? Yes, you can. If we were dividing 18 by 6, the remainder would be 0, right? So we know it can be 0. Can it be 1? Yes, 19 would work. That would give us a remainder of 1. Can it be 2? Yes. And it can be 3, 4, 5. Can it be 5? Yep. 23 would give us a remainder of 5. What about, can it be 6? Well, the answer is no. You can't have a remainder of 6, right? If we have 24, instead of having divided by 3 and have a remainder of 6, we would actually be able to divide it by 4. So if there's a 6 left, then it divides one more time. So the remainder is always, the smallest remainder is 0, and the largest remainder is always the number minus 1. Okay, so if you're dividing by 6, the divisor by 6. It wouldn't be 22 minus 1, right? It would be the divisor minus 1. So if we're dividing by 6, then the remainder can be from 0 to 5. If we're dividing by 12, the remainder can be 0 to 11. So whatever we're dividing by, the remainder goes from 0 to 1 less than what we're dividing by. And so that's the limitation on the remainder. So we have all of these to work with then as we're learning this algorithm for how we move through a division problem. Now I'm going to write this a little bit different so that it doesn't look like we have two subtractions, right? It's 0 to d minus 1, the divisor minus 1. So we want to keep that very clear how we're using that remainder and what those limits are. Now, when we're working with integer division, we actually have two operations. One that gives us the quotient, right? That's the div operation. And one that gives us the remainder, which is the mod operation. We call this division and modulus, but we're abbreviating them here as div and mod. And so we can do a few of these, right? So we can say, well, we've already done 22 div 6. Let's do something else. Let's go 38 div 8. Shall we do div 8? What does that equal? Right? What do we get when we take 38 div 8? What we do is we take 38 and we divide it by 8. So how many times will it go in there? It'll go in there 4 times, right? And then we also have 38 mod 8, and that gives us the remainder. So when we divide by 8, it gives us 4, which is the 32 part, and then we have 6 left over. So the remainder is 6, right? Because 4 times 8 is 32 plus 6. And this is the way that you can test it. So remember that this is our quotient. So let's see if we can just identify these. So our number is 38, right? Our divisor is 8. Our quotient is 4, and our remainder is 6. And so those are each of those values, right, that we've been working with. And notice that 6 is in the range of 0 to 7, which is the possible remainders, and that our divisor is not 0. So we followed all of the rules, and we've identified what those 4 values are. Now we can test them because it is always the case that now we can take the divisor times the quotient and add the remainder, and that will be equal to the original number. So let's go ahead and do that. So we take the divisor is 8 times the quotient, which is 4, and then we add the remainder, which is 6, and what do we get? Oops, equal. So 8 times 4 is 32 plus 6 is 38, and that's how you can verify that everything's been done correctly, because it's the divisor times the quotient plus the remainder equals the number. And so you can do the div operation, the mod operation, get all of your values, and then you can verify it with this formula.